plus 4, which is 6. And then negative 1, subtract negative 9. So negative 1, subtract negative 9. That's really negative 1 plus 9, which will give you positive 8. Okay, and generally, you notice that 6 over 8, you want to reduce to 3/4. Okay, so generally, you want to reduce the slope if you can. And then looking at question number 6. Okay, now we're going to, if you're given the graph of a line, you want to be able to write the equation. Well, again, the idea is when you write the equation of a line, you want to be thinking y equals mx plus b. Okay, so if we just start with, suppose we start with this first one here. The y-intercept on that line, it looks like is positive 1. So it looks like there's a nice point that it goes through. And it looks like another nice point that that line goes through. Okay, it looks like maybe at this point here, 4, negative 2 is another nice point that line goes through. Okay, so to write the equation of that line, y equals mx plus b, y equals, okay, and then we know that the y-intercept was plus 1, but the slope of the line, it looks like we have to go, to get from this point to this point, we go down 1, 2, 3, and to the right 1, 2, 3, 4. So down 3 to the right 4, there's down 3 to the right 4, times x plus b. We know the plus b value is plus 1. So the equation of that line, it looks like, is y equals negative 3/4 x plus 1. Okay, the next line here we'll look at is this increasing line right here. So we know the slope should be positive. Okay, the slope in that last one was negative because the line was decreasing. Okay, so this line here is increasing, so we have a positive slope. It looks like the y-intercept is at 0, 0. And it looks like the next nice point, maybe right here. Okay, so if you look at that pattern, it looks like the y values go up by 2, and you go to the right 3. So y equals, the y value went up by 2, the x value went to the right 3, so times x. And then plus 0 is really just leaving nothing on your equation. Okay, so there's, you don't have to put plus anything. So it looks like y equals 2/3 x is your equation for that line. And then the last line here, this decreasing line, we know it should have a negative slope because it's decreasing. It looks like the y-intercept is at negative 4. And it looks like we can find several nice points on there if you go down 1 to the right 2. So y equals down 1 to the right 2 is negative 1/2 for the slope, and then times x plus b. So really plus negative 4 will be minus 4. Okay, so there's the equation of that line. Okay, moving right along to number 7. So given the table, we're going to determine if we have a linear relationship. If so, find the slope and write the equation. Okay, so in order to be a linear relationship, that means we have to have a constant slope. Okay, so what that means is, between any pair of points, the rate of change, or the slope, has to be the same. So one way to find in a table of values the slope, technically what you're doing is you want to do y2 minus y1 over x2 minus x1, what we did up here on the top of this page. You want to do that for every pair of points. Okay, technically that's what you want to do. Now there is a shortcut to that. Okay, one shortcut is when you look at the change in the x values, to get from 0 to 1, we add 1. And I've already done this several times in different videos. From 0 to 1, you have to add 1. From 1 to 2, you have to add 1 again. From 2 to 3, you add 1. From 3 to 4, you add 1. So it looks like the x value always goes up by 1. And then what happens with the y values? Well, from negative 1 to 2, to get from a negative 1 to a positive 2, you have to add 3. To get from 2 to 5, you have to add 3. To get from 5 to 8, you have to add 3. From 8 to 11, you have to add 3. So what we see there is, when you're looking at slope, remember you're looking at the change of y over the change in x. the change in y is 3. Okay, so let me say slope equals. The change in y is always positive 3. The change in x is always 1. So 3 over 1, 3 over 1, 3 over 1, 3 over 1. Remember, we're looking at the y over the x, not the x over y. A lot of people say 1/3, and that's wrong. You're going up 3 to the right 1, because the slope is change in y over change in x. So the slope here, it looks like, is always, between every pair of points, 3 over 1. Now those numbers, another way you get those, the same way as up in number 5 up here, by using that formula, but we just did a shortcut. If you use the formula, what you'd really have to do, for that first pair of points, you would say the slope equals y2 is 2, y1 is -1, so you would say 2 subtract -1 divided by 1 minus 0. Well, what is that? Positive 3 over 1, which is that ratio. Okay, and then you would have to do it for the next pair of points, which you can see gets very time-consuming and just a lot of work to show. So when you have a table of values, doing this plus 3, plus 3, plus 3, that's a good way to show how you get the slope rather than using the formula y2 minus y1 over x2 minus x1. Okay, so is this table, is that representing a linear relationship? Okay, yes, okay, because the slope is constant. Okay, slope is always 3 over 1, or just 3. So now that we have a linear relationship, what is the equation? Well, remember, y equals mx plus b. Well, we have the y equals mx part, so y equals 3x plus b. Well, remember, the plus b value is the y-intercept. Well, the y-intercept always occurs when x equals 0. When you look at each of these, in the previous example up here, the y-intercept for this line was 0, -4. The y-intercept here is 0, 0. The y-intercept here is 0, 1. Notice that the y-intercept always occurs when x equals 0. Any point on the y-axis has an x value of 0. For example, a point right here, that would be the point 0, 5. Right here would be 0, 6, 0, 7, and so on. So the x value is 0. In our table of values, when the x value is 0, the y value is -1. So our equation of our line is y equals 3x minus 1. Okay, and the next one, okay, if we look at the x values, from -2 to -1, we add 1. From -1 to 0, we add 1. It looks like we keep on adding 1 to the x. The y values, from 10 to 6, we have to subtract 4. Notice that's the same thing as 6 minus 10 is -4. From 6 to 2, we subtract 4 again. From 2 to -2, we subtract another 4. And then from -2 to -6, we subtract another 4. So what we notice is that the rate of change is always going to be the same thing, -4 over 1. So the slope is -4 over 1. So is it linear? Okay, yes, because m is always -4, or -4 over 1 if you prefer. So the equation of our line, y equals mx plus b, we know y equals -4x, and then plus b, well again, when the x value is 0, the y-intercept is +2. So plus 2 will be our b value. So y equals -4x plus 2 will be the equation of that line. Okay, moving along to part C. Now we have a horizontal table, but don't let that throw you off. The x values change from 0 to 1 is adding 1. From 1 to 2 is adding 1. From 2 to 4 is adding 2. 4 to 6 is adding 2. Now, a lot of students will be confused and say, well, gee, that can't be linear because we add 1 to the first two values and then we add 2. But remember, when you're looking at slope, you can reduce the slope to the same number. So for example, that 1/2 slope from before, the same slope was 2 over 4, or 3 over 6, or 4 over 8. or negative 2 over negative 4. Okay, so as long as they reduce to the same value, then you may still have a linear function or linear relationship. So just because the x values go up by different amounts, you can't just stop there. Because remember, the slope is the change in y over the change in x. So you can't just look at the change in x and say it's not linear. If we look at the y changes, from 4 to 6 we add 2, from 6 to 8 we add 2, from 8 to 10 we add 2, from 10 to 12 we add 2. So now when we're looking at that, the slope changes from 2 over 1 to 2 over 2. So they do not reduce to the same thing, so not linear. Okay, so here, just for the sake of time, the slope changes from 2 over 1 to 2 over 2, so therefore not linear. Okay, so if it's not linear, we can't write the equation. Okay, so we're done with that question. Part D. Okay, again, I'm going to suggest you try this one and see what you come up with. Okay, but I'm going to put the change in the table here just to show you. Okay, so the x values go up by 1, then by 2, then by 4. And the y values subtract 3. Then from 9 to 3 you subtract 6. From 3 to negative 3 you subtract 6. And then from negative 3 to negative 15 you subtract 12. Now the big question is this linear? Well, when you look at the ratios, negative 3 over 1, negative 6 over 2, negative 6 over 2, and negative 12 over 4. If you reduce all of those, negative 3 over 1, negative 6 over 2, and negative 12 over 4, okay, that's a 4 right here. They all reduce to negative 3. So the slopes are all equivalent. So we have a linear relationship. Okay, and that's something that's very tricky for people to understand, but it has to do with those ratios reducing to the same value of negative 3 in this case. So the equation of our line, we know the slope is negative 3, so y equals negative 3x, and then plus b. Well, the b value happens when x is 0, y is 9, so the b value is positive 9. Okay, so y equals negative 3x plus 9. Okay, then the last question on here, okay, number 8. Okay, we're looking at a table of values that represents a linear equation. So they're telling you this table is linear, and you want to fill in the missing values of the table and write the equation. Now this is a higher level thinking question, okay, so it's a bit tough. Well, remember, in order to be a linear equation, that means constant slope, which means, just like in that last example, your slope has to reduce to the same number each time. So whatever pair of points you're looking at, the change in y divided by the change in x has to reduce to the same thing each time. Now I suggest you pause this and try to think about how would you actually do this question. For the sake of time, again, I'm just going to go on. Okay, but pause the video if you need to think about it. What we look at is, notice how we have 2 points given right off the bat, negative 4, 7 and negative 2, 1. The x value goes up by 2. So from negative 4 to negative 2, we have to add 2 to x. The y value goes down by 6. So we know the slope is change in y, which is negative 6, over positive 2, which reduces to negative 3 over 1, or just negative 3. Now what that's telling us is, every time that y goes down by 6, the x value had to go up by 2. Equivalently, it's saying that every time y went down by 3, x has to go up by 1. You could also look at it as, every time x went up by 1, y had to go down by 3. Or, every time x goes up by 2, y has to go down by 6. So if we look at the next pair of points, so from the point negative 2, 1, so from that point, we know the x value went to negative 1. Well, what did x do? It went up 1. Well, whenever x goes up by 1, isn't that this piece right here? So when x goes up by 1, what did y have to do? Y had to go down by 3 in order to be linear. So if you take 1, subtract 3, we get negative 2. Now what happened in the next pair of points? Again, x went from negative 1 to 0, so the x value went up by 1 again. Well, when x goes up by 1, what does y have to do? It has to go down by 3. So negative 2 take away 3 is negative 5. Okay, and then what happened? Well, we don't know what x did, but we know that y went from negative 5 to negative 8. So that means the y value went down by 3. If the y value goes down by 3, the x value had to go up by 1. So 0 plus 1 gives you 1. And then what happened? Well, we don't know what happened with the y's, but we know the x's went from 1 to 4, which meant that x had to add 3. So if x adds 3, what does y have to do? Well, we don't have that ratio here, but if we think about if we go up by 1 for x, y to go down by 3, now you're doing that 3 times. So if x went up by 3, y has to go down 3 times. So negative 3 times 3 is negative 9. Notice negative 9 divided by 3 reduces to negative 3 over 1. So the y value had to go down by 9 if x went up by 3. So negative 8 take away 9 is negative 17. Okay, so that's filling in the table. Okay, so we did that part, fill in the missing values. Write the equation. Well, again, y equals mx plus b. Okay, which means we have the slope was negative 3. So negative 3x, and then plus b. Remember, the plus b value always comes when the x value is 0. What was the y, or the y-intercept? Minus 5. Okay, so there's the equation of our line. Okay, and then looking at the last one in part B. Okay, in part B, we don't start off with 2 points. The only 2 points that we have come from this point and this point. So negative 3, and 3, 1. So to get from that point to that point, the x value went from negative 3 to 3, which means we had to add 6. The y value went from negative 3 to 1, which means we had to add 4. Okay, so if we had to add 4 to the y value, okay, so we have the slope equals adding 4 to y every time the x added 6. Well, that's the same thing as whenever x goes up by, whenever y goes up by 2, x had to go up by 3 if we reduce that by 2's. So we can use those ratios to help us fill in the table. Okay, so again, whenever y goes up by 2, x had to go up by 3. Or every time x goes up by 3, y had to go up by 2. You can look at it that way. So just looking at from negative 5 to negative 3, didn't the y value go up by 2? So when y goes up by 2, x had to go up by 3, didn't it? Well, what do you have to add to what do you have to add 3 to get to negative 3? Okay, this is a little tricky to think about. So think about if you add 3 to what number here, do you end up at negative 3? We could start at negative 6. Because negative 6 plus 3 gives you negative 3. Okay, that's tricky. The next pair of points, x went from negative 3 to 0, so we added 3 to x. So what happened to the y value? We had to add 2. So from here, you have to add 2, so plus 2. Negative 3 plus 2 gives you negative 1. And then notice how y added added 2 again. Well, that means you added 3 to the x, and that matches up. Here, from 3 to 9, you had to add 6 to the x value. So if you add 6 to the x value, Okay, adding 6 to the x, okay, to get you from 3 to 9. And then if you add 6 to the x value, you have to add 4 to the y. So 1 plus 4 gives you 5. And then notice from 5 to 13, we add 8. So if the numerator was adding 8, you have to add 2 4 times to get 8. So you have to add 3 times 4 to get to 12 change in x. So if you add 12 to 9, you get 21. Okay, so there's the table of values, and that one's a tough one. But the equation, y equals mx plus b, we know the slope of that line is 2/3 times x, and then plus the b value will be plus -1, which is -1. Okay, so y equals 2/3 x minus 1. Okay, so that topic, that was a long video, but the topic is very important. One of the most important concepts in the class of finding slope and using slope to help you write the equation of a line and graph the line, okay, rather than making a table of values each time.